Well, hey everyone, and welcome back to another Unity formation tutorial. This one is going to be working on the triangle formation we've already done, and it's going to allow us to be able to choose a direction in order to make the formation. We can go ahead and get started on that. Alright, so what we'll do is we'll go ahead and open up the formation controller script. We'll come on here, we can comment out this. Not gonna need that. We can leave that alone for now. We don't need the circle formation, the square, spiral. We'll need the triangle. Then we can do the half circle, nope, and sphere. Okay, so there's some things we need to do in here. The way it is set up currently is it's offsetting to where when we create the triangle, okay, which we can go through and show you. When we create a triangle, it's just gonna go up here, and when we click play, it's gonna draw this. It's gonna draw the triangle. Well, notice the arrow is pointing up. So what we're gonna do is in this tutorial, get it to where it points down, points to the right, or points to the left. So we just need to add some directions to it. So let's go ahead and get started in that. Come on. Oh. Okay. So that's the triangle formation. So let's go into here. What we need to do is come into here where we create the positions. We're gonna do some finagling here. What we're gonna do is come up here and we're gonna make a private enum and we'll call it direction, and we'll have the direction of up, down, left, and right. Okay, this will determine what direction is going to be. The triangle formation will take in the parameter for it'll take in the parameter of a direction. So we're going to tell it, hey, what direction do you want to process? You want me to draw it? So we'll just do this. Like that, simple. That is it. And then for coding convention, come down here. And just like it did over here with one of our other ones, param. So we can actually take this, copy it, come up here, this, 1, 2, 3, and the parameter is actually going to be direction, and it's actually the direction the triangle should point. Okay, then we'll save it. So when we come into here, right now we have it set up to where it just points up. So we already technically have that direction. We're going to put in some tertiary operators. So what we'll do is we're going to come into here and we're going to reset this. So this will work if we do the up and if we were to do down. So let's work on the down first so I can show you how it works before we get too involved in it. So this will be up now. So we'll come into here. We want to do it on the down. So we know right now when we set this position here, okay, so we know when we set the position here, this is for when we want it to be up or down. Okay, this won't change. The x offset is on each row. How the space between, we're going to rename this, but for namesake at the moment, x offset means how much in the x axis do we offset each sphere that we draw. Every instance of a game object we create, they have to be a certain distance apart. That's what this offset is. And it's going to come down here. After that row is over, and go and produce it for the next row. So the way it's going to work on the next row is this part's going to be a little different. So right here we have it set up to where it's in the up direction. Well, if we want it to point in the down, so we can actually make a note, up direction. Okay, come into here, drop a space. We can copy this right here, right onto the next line, paste it. Okay, so now we know this is the up direction. Well, we want it to face down, so we have to change some of this in here. In order to face it down, this row offset and this will stay the same in the X, but it's the Y that's going to change. Instead of going positive in the Y direction, we're going to go negative in the Y direction. Okay, so we'll just do this. We're not doing anything with the enums or anything yet. We're simply just going to come into here and say, okay, when we draw this, we can just pass in anything for right now. It doesn't really matter. So this doesn't matter. Keyboard functionality. There we go. Awesome. Okay, so you can pass in anything right now. We're not using it yet, but if you come back into Unity, okay. Now when we draw it, we should have a down arrow. See? Now the arrow is pointing down, and that's what we want. Well, we got to have a way that we can go into the code and we can call this with much, better functionality. Because right now we want it to go down, yes, but we should be able to change this and say up, down, left, right, however we want to draw it. And that's when this is going to come in. So inside of here, now that we know this is working well for up or down, we need to come into here and find a way to say, okay, so depending on what we're going to do, we need to be able to go up or down. Okay, cool. So what we can do is we can make a simple switch statement, and it'll be the direction. Maybe this. And inside of here we can do case direction dot up. Okay, and it'll actually be this here. We're going to set the target direction to this. Enter this, enter, and then we'll break out of the statement like that. And there you go. That is our first statement. Well, then you would come into here and let's just do this real quick. Okay, and then we'll have one for case direction dot down. Normally, I would only use a tertiary operator to do this, a ternary operator, but because we're going to have 4 different directions, I'm going to use a switch statement here. It'll make sense as soon as we do the left and the right directions. So we know down is this. So we do copy, put that there, enter, and then break. And we'll just leave that for now. Okay, we'll just close this off for now. So now we have an up and a down direction. So that means if we come up here, and for this, what we'll do here is we can do private instance of a direction, and we can do triangle direction like this, and then we'll just serialize the field like this. And then we can take this triangle direction, put it in here, save it, go back into Unity. Now we go to the main camera where we have our attached formation controller on. Let's set the direction to up. Come into here. We should have the arrow and it points up. Oh. Interesting. Will it work with down? Yeah, but there's some funky stuff happening. Okay, well let's go ahead and resolve it then. Let's see what we got going on. So come over here, triangle direction is up down. Okay, it's not that. So we'll come into here. Okay, this is gonna work regardless because we just did up down no matter what. Okay, yeah, we need to take this out. Okay, so that was causing issues. Okay, now it's gonna work. So we have it set to up. Now it should point them up. Boom. And you come into here, down. And there you go. Now you got the down arrow. Now we gotta do left and right. Left and right is a little bit more, but it's not as bad as you might think. So what we can do is we can leave that alone for now, so you kind of understand what's going on here. So all of this essentially works for up or down, but it becomes a thing when you want to do left or right, and I'll show you why. So let's see. So this offset is for the left. So this says we're going to be drawing a triangle that points up or point down. So we want to offset the starting point with -1. So when you add the 1 on the first iteration of the loop, it'll actually start at 0. Well, we want to do it a little different if you're pointing left or right. Like we can actually leave this and I'll show you what it does. So we can leave that for a moment. And then we'll come into here. This is determined on the offset if we're drawing side by side on rows, but we're not. We're actually wanting to go pointing left or right. So actually they're not going to draw side to side. They're going to kind of draw top to bottom of one another. You'll understand what I mean in a second. So we'll just copy it. We'll put this. So in order to do this, we're going to take this, copy it, put this here. Instead of adding the offset on the X position, we're going to add it on the Y position. I know it looks confusing because it has X offset, but we're getting ready to change that so no one gets confused. So just bear with me. So basically what this says is when we draw up or down the arrow direction, we need to space them out on their width on the X axis. Whenever we draw an arrow a triangle that's going to point to the right or to the left, we need to space them out on the Y axis separately from one another. So with this being done, now we would come into here, and what we would do is we would just create a case statement for direction.left. Okay, now the way it's going to be drawn is a little different. We can copy this because we're going to change some of this. So this is going to be direction left. So the way direction left is going to work is the math on that is we literally swap the X and the Y values. So that means if you go left, this Y offset, this minus is actually going to go in the X position, and the X is actually going to now be the Y position. This is what it's going to look like. So now when we go up to the top, we get out of this, go back into here, and I'm going to step you through the code. We'll come back into here. I want to draw left. You hit F. The arrow should be on this side pointing this way. Okay, now the reason we're having this issue here is because we did not, because of this offset right here. It has to be different. So what we would do is do this, set it to a different vector, which would actually be a new vector 3, okay, we still want the offset in the x position, but now we want the offset in the y position. This is the new offset position. So when you do left to rights, you gotta do these. Up to downs is this one. I know it's confusing because this is left, but we're getting ready to change all of that, so it'll be a lot more understandable. So we'll come into here, save it. We still want it to draw left. And there we go. Okay, still an issue. Let's go ahead and fix it. We will get that resolved. Let's see here. Make sure. So if we want to go case direction left, target position is going to be... see. We're not doing the Y. We're doing the X. So target... Because remember, when we switched these around, we did it correctly. But this isn't the X position. This isn't the Y position. It's the X. That's why this one stopped working the way it is. It can't be the Y position in the offset, as this is the X part of the vector 3. So you need that. And then this up here does need to be -1, -1. So awesome. That should make a huge difference. Beautiful. And there you go. So now you have a triangle that's pointing to the left. Okay, well, cool. So now how do we do the right? Well, it's pretty much it's the same thing, just like we did earlier with the up and the down vector. So we know we can come here, copy this, paste it, change this to right. Okay. So now we want it to point to the right. Instead of the Y, instead of minusing the offset, we're going to add the offset. Right there. And yeah, that's it. That should do it. Oh, we didn't change it. We gotta change it from left to right. Bam. And now the arrow's pointing to the right. So that's awesome. So it works. We got all 4 directions. What we're going to do is we're going to go in here and clean up some of the code real quick to make things just better, much more understandable. So we'll go inside of here. Okay. So we needed something here that's going to be able to judge the two. So I'm going to put a ternary operator in here. So what it's going to say is we're going to have the vector 3 target position, okay, and it's going to be set to direction equal to direction dot up or direction equals dot down. Okay, so what this is saying is come over here, put a question mark. And we're gonna say, okay, so this would be a new vector 3. I'm gonna go through it. -1, 0, 0, bam. Colon. And then new vector 3, -1, -1, 0. Parentheses, semicolon. Okay, so what is this doing? It says, hey, let's create a variable called target position. If the direction that was passed in is up, or if the direction is down, that means it's true. I want you to take target position and set it to this. If these are false, if it's not up and it's not down, then I want you to set the target position to this. So that means if you want it to point up or down, I want to set this vector as the starting target position. If it's pointing left or right, I want it to start from this target position. That's all that it says to do. So then when we come into here, So we can start with the up. We can go through all and we'll do up. Oh goodness. Up, let's see. It's like, well then. Oh, yeah, that's what I did wrong. It doesn't need to move in that direction. It needs to be 0. Yeah. And that's it. That's what it needs to be done. You don't move in the x-axis. So if it's up or down, move it, you want to space on the x. If it's going left or right, you space on the y. Just the y. Now that's going to work. And this is going to be up, so it's going to point what is happening. I'm saving the scene. Something's funky here. Okay. So let's see. Target direction is set to direction up, or direction is set to direction down in a -1. You're -1. Okay. So let's see. Oh, that's what it is. We didn't do another one for this one. Okay. So that's what it is. Well, that did fix that one issue. So what this means is, remember, we don't know if we're moving up or down, or if we're going left or right inside of here. So we got to do another. So we'll do another one of those ternary operators, actually. So we'll come into here, and again, we'll do target position is set to, and then again, we'll do direction equal to direction dot up, or direction is equal to direction dot down. It's gonna be the same thing as before. Okay, we're just gonna reset it. So that means we know it's gonna need to be, if it's up or down, we're gonna be a new vector 3, which I think we already wrote here. New vector 3 target position, this one. So if it goes up or down, this is what we want, this vector here. So if it goes up or down, we're going to set it here. We're going to offset it on the x. If it's false, target position. If it's sideways, in the other direction, we're going to set it to this way. Like this. Figure that out in a moment. Okay, so like this, comment that out. We'll figure out why that's going to go and give us an issue. New vector 3. System ambiguous difference? Really? This is this one. Why are you acting that way? Oh. That's why. Yeah, that's not supposed to be that. That's a unity vector. That's supposed to be a unity vector. Why in the world is it giving me that kind of issue right now? Unity, who put that in there? Oh, typing so fast. We don't need all that. Alright, yeah, that resolved it. Goodness. Okay, so, alright, so that's done. Now we're inside of here. Direction down. Okay, so if it goes up or down, we want to offset on the x. If we want to offset on the y, if it's left or right. Correct. Commented it out. Okay, so now when we go in there, everything should be working appropriately. Now we're going to draw up. Okay, so there's your up. Here's your down. Boom. Here is your left. Okay, arrow points left, and then here's your right. Boom. And that's how you do it. And we'll clean up the code really quick by moving some of the stuff around. So this is all code we don't need here. Okay. Got all of this. Okay. Right. Okay. Yes, take this out. Alright. I'm just taking out the code for all you guys. Put in the comments later. Okay. So yeah, that's the target position there. Now we're gonna go just rename some variables just to have a bit of a better convention with it. So inside of here we got all these offsets, right? Well, now that we can do different directions, we need to change that to better. So we know we have a number of rows. We know how much to offset each row by. But now what we need, instead of the Y offset, this is the height offset. And instead of the X offset, this would be the width. These offsets are how far apart each sphere is from one another after instantiation. So when you have 3 spheres lined up next to each other, how far are they apart on the width is this. If you have 3 of them and then 3 below them, how far they are above one another. That's the height offset. So we just go into here and just change those. We know the X offset will be the width. And we know this will be the width because we're separating the difference. We're separating them between each instance that spawned. And then inside of here, these are going to be height. And the reason we do the height here is because when we break from this loop right here, this loop is the one that does each individual sphere in a row. So when you space the row, each sphere in a row, you have to know how far do you place them from one another. That's what this is. When you're done with a row, you say, okay, I'm done with the second row in the triangle. Let's go on to the third row. You come into here and say, okay, third row, we're up, our direction is up. I need you to offset the X position accordingly, but I need you to set the target position from the sphere that's above me by this much of an offset, so we don't overlap one another, we don't touch each other on the y-axis. That's what that is for. And that's pretty much it. If for some reason you don't want to go through all of this, okay, that's completely understandable. There is one thing you can do. So remember inside the scripts, we have a container component. Well, it's attached to our component. Our container. Realistically, if you go into here and we rotate this on the z-axis to make it even better, let's make this go up. I want to show you something. So let's say you don't want to do any of that coding and you just want to be able to just do it a little bit simpler. Okay, we'll come into here, play, let it draw the up triangle. Okay, cool. You can come onto this container, which contains all your spheres. If you rotate it by 90 degrees, look. If you rotate it by another 90 degrees, that's 180. You got a down. If you do it by another 90 degrees, 270, look. You get your right arrow. You still get your arrows. If you want to rotate these in the program, you can do that. So if you don't feel like writing all of that code to generate things like that, you can just do you can just encode whenever you spawn the object, set its rotation to whatever you want. That's all you have to do. You want that left pointing arrow, go ahead and set the rotation accordingly. Every 90-degree angle will go ahead and give you a direction pointed. And from that, you're pretty much good to go. So, I appreciate y'all taking the time to watch the video. I hope you enjoyed it. Pray all of you have a blessed weekend. Y'all be safe out there. And I will chat with y'all later. So, later.